So in this video we'll continue, hopefully wrap up the next few trigonometric limits. In problem 13 we have the limit as x approaches infinity of sine of 1 over x. And so we want to remember that 1 over infinity, even though infinity isn't really a number, but 1 over an infinitely large number is really just 0. Or in the terminology of this section, the limit as x approaches infinity of 1 over infinity is going to be 0. And so what that means then, in this particular case, this is a function composition. We want to take the limit of the inside function and simply plug that into the outside function. Well, the limit as x approaches infinity of 1 over x is 0, and sine of 0 is just 0. Okay, and the next one, limit as x approaches 0 of x squared sine x over 1 minus cosine x. Now when you see something like this with 1 minus cosine square x, you might want to remember your Pythagorean identities. If sine square x plus cosine square x equals 1, then that means that 1 minus cosine square of x is just going to be sine square of x. So we replace the 1 minus cosine square x with sine square x. Now, this looks a lot like one of the previous ones where we have limit as x approaches 0 of x over sine x. Only we have two of them, so we're going to multiply x over sine x times x over sine x. That would be x squared over sine square x, but we still have a sine x left. And the two x over sine x's will cancel to 1, become 1. And so we end up with simply limit as x approaches 0 of sine x, plug in the 0 for x, and sine of 0 is 0. Number 15 is similar to the problems we've seen previously, but a little more complicated because we have sine square of 7x, sine square of 11x. And so if we broke those up in the numerator, we'd have sine of 7x times sine of 7x, then over sine of 11x times sine of 11x. And that's okay, we'll just divide the numerator by x squared and split it up, and the denominator by x squared and split that up, which basically means we're dividing the numerator and denominator both by x squared, which is going to leave us with the same or an equivalent value. We're not changing it in any way. But just like above, in order for the sine of 7x to work, we need a 7x in the denominator. But then we'd have to multiply by 7 also. And the same with the second one, and the same with the 11's in the denominator. And so, in the numerator we have 7 times sine of 7x over 7x times 7 times sine of 7x over 7x. Same thing in the denominator, or similar I should say. You have 11 times sine of 11x over 11x times 11 times sine 11x over 11x, and each of those is going to become 1, limit as x approaches 0. Only this time when we simplify, we don't just get 7 over 11, we get 7 times 7 over 11 times 11, which is 49 over 121. In problem 16, we have limit as x approaches 0 of cosine x minus cosine square x all over x. We plug in 0, we're going to get 1 minus 1, which is 0 over 0. What we want to do here is try factoring out. And so we get the limit as x approaches 0, factor out the cosine x, and we're left with 1 minus cosine x over 0, over x. And we know that that piece on the right is just 0. And even though we plug in 0 into the other cosine of x and get 1, 1 times 0 will be 0. The limit exists, but the limit is 0. And that'll do it for these three problems here. We'll go on to problem number 17 in the next video.